So I thought I'd get behind the camera. I've not been doing it, or get in front of the camera. I wanted to show you the second stage. It's purely to replace the spindle, which doesn't have the ability to change the tools very quickly unless I get my spanners out, release the collet, take the tool out, put a new one in, touch it off, carry on. But this can be tedious, so I wanted to use these, which are the TTS collets that you can get from Tormac. There's been some versions that are out there which are kind of, I guess, rip-off ones. I have one or two from, I've been collecting them over the years, and I have some Tormac ones, so I'm very happy to have that. This is held in by an R8 collet. I think it's a 3/4 collet. Well, I know it is a 3/4 collet, which is 19mm for those that don't know what inches are or those measurements are. Bit of old English measuring. This simply pops into this collet, gets held in. The collet is closed by springs on the other side. You've got some Belleville washers, and they're literally tensioned to the point that this won't come out or rotate when you're trying to cut with it. That's great. But first of all, you need to release that collet and get that force off from closing it. Sorry about the dog barking in the background. I think he wants to get in on the video. So these springs will be on this side of the collet. They will be stacked up here, but we've got to compress them down. And as you can see in the video, I'm going to have a plate that sits on here, which then supports my collection of parts which create the housing. So I have my bottom plate, which will sit underneath the spring washer, and it will pull up and basically relieve the springs. They won't have any work to do anymore because it's all been relieved. Now have a nice day, thank you very much. So that's the bottom plate. I've then made these other sides. These will bolt on. A kid crying in the background, don't know if you can hear it. But basically, it's really loud. So these will bolt together. You'll see on the assembly on the computer. You have the top piece, which then has our pneumatic cylinder. Didn't mean to hit that with my arm. And that will come down and push my control rod, which then releases it. But you'll see more of it when it actually happens, but you just have to trust me, it should work. Put a bit of time into this so it better work. So that's basically it. I have the tensioner which I've made, nice simple piece. Again, if you follow me on Instagram, you'll see that I did this bit a long time ago now. And that simply bolts in here. I have my belt drive mechanism in here. The biggest advantage I have having the belt drive is I'll be able to have a small pulley to drive from the original spindle motor that I've been using. So the spindle motor will become the motor. This is 2.2 kilowatt, 24,000 RPM. I use this small pulley that will screw in place where normally a tool would be, and that will drive this 60 tooth pulley with whatever reduction in gear ratio that I need. So that should be great. To talk about this for its structure, I've got a simple 10mm plates at the back, which will screw onto the original machine where the spindle used to go. Then I have 10mm plates on the side and the bottom, which all bolt down a squared off extrusion, which I've had machined. I say had machined, I had a company called Vale Engineering. They machined both sides and made it perfect for me, and then I've got it on my Myford mill, cleaned up the bottoms and the sides, so when all this stuff bolts on, you're nice and square. And then I machined an extrusion, machined through the extrusion to allow the spindle, like I said, that Hawkins Engineering made for me, and yeah, it's all together. I'll have some more bolts to go into it once I've finished. You can see it's all empty at the moment, but this is all going to come apart. I'm going to take it to the plating shop. They're going to anodize it for me. I'll go for a nice blue, make it look really good. Some other parts I might have in red, and we'll just see how that all looks. But I want to get all my parts done first before I go there, obviously, and that's why I want to get some of these parts that you'll see over this video and the next video completed, so I can get that done. Let's show you how to program this. I'm using Autodesk's Fusion 360. It's a brilliant little program to use, and it's free on trial form, or if you're a hobbyist. So I'm just going to show you how I set this up. So I have to set up my stock first. So this is a 6mm plate, which I then have to, it finds itself around the work. You set how large you want the work to be. You find your corner. We go into edit. I'll bring the box over and show you what we're doing, but I put the corner up here for the 0, 0 position for the stock. If I just bring the little box over here, you see I've got, it's 152 by 120mm, so it's not large, and here you can specify where you want your stocks to start, and you just do it to your convenience. So then we have the contour. We go 1mm steps down with a a single flute 3mm cutter from Cutwell. Then we do a cleanup pass. Then, as you can see here, the adaptives, so obviously they swirl out after drilling a hole down. And then you have the contours of the little holes, so they just machine down. I should have probably used bore for this one. I'll do it next time. Have a little play. I'm still learning. It's all part of the fun, really. And then we have the outside contours, which are 1mm steps again, just to rough it out with a 0.1 clearance, I think. And then we contour off to basically just clean up that profile. And the last bit's the chamfer. I'm using a CNC spot drill for this one, and that just comes down, it cleans that up. I got this one off eBay. Again, I don't know where it's from. I need to have a little look and find a source, so then if any of you want to do it, you can try it yourselves. Basically I have a 1mm offset, so you get a bit of surface speed from the cutter, because it doesn't turn very quickly right in the centre. And now we'll do the simulate. It just allows you to check to see if you've messed up here when you're trying to machine. So I click on the box, I bring that over again. So I click on flute. So then you just see the flute. I don't want to see the toolpath. I want to see the stock, and I want to see how it's machined. So click material for the colorization, and pick our speed at the bottom on this little bar here, a little bit slower. And we can watch it speed through, making its cuts. You can see if it's doing anything stupid. If you are worried, you can go really slowly and watch if it's going to trash into something after doing all that hard work. This is a simple job. Just done the 8.5mm holes, do the 4.5mm holes, doing the outside contours, and then we're just going to do a cleanup pass. And you can see a lot more blue pops up on the cleanup pass. And so it's just cleaned it off. No, you couldn't really see much there. But that's our chamfered edge. It's all appeared. So let's go set up the stock and go make it. So I'll just show you the technique that I'm using to hold it down. Again, I'm using tape. It's a painter's tape by 3M. It's an edge lock Scotch tape. It's very good. It stops the work coming off, and I use the glue on the to hold it down between them. So my plate has tape on. This has tape on. So you just need to make sure everything's clean. Just make sure there's no grease on it and no moisture or anything. Just super clean. And then that gets stuck down. I use 2 little dowel pins now, and they're to help square the work off when I put it on. And then I get some super glue. And just to remind you, this is the John Saunders NYC CNC gluing down technique. So all the glue will be stuck down in front of us here. So I don't put crazy amounts on, I just put, I think, enough on to get a nice even layer. So I just kind of space it out, just whatever. You just need to make sure you cover the area that you want to hold down. If you go crazy, I think you might have some trouble with it, I don't know, just not curing properly. But I think I put the right amount on there. I push against the pins, I push it down, give it a good old squish. Seems happy, and there you are, absolutely fine. So just let that dry off for like 20-30 minutes if you want. Spray some activator on the outside, it'll be fine. So I've loaded up the job. There you can see, so there's the code in there. You can see it's got 2 tools. I've set up the 0 already for the stock piece, as I already showed you. And then it's going to take 22 minutes. You can run the simulation just to see how much it tallies up with Fusion. Yeah, let's get going. So, yep, I've set up my 0, 0. This is my nice little single flute cutter, and we're going to make something with it. So my single flute.
Let's start taking some cuts. I'll speed up the video so it doesn't take too long, but off we go. I've removed the inner circle and the periphery parts, mainly just so when the shampoo tool comes round, the outside edge possibly could get close to that stuff, so I didn't want it to upset anything, so we'll get this going.
I'm just sitting here, I got time. It's clear to see from up here, the world seems small. We can sit together. It's so beautiful, you and me. We meant to be in the great outdoors, forever free. Sometimes you need to go and take a step back to see the truth around you. From a distance you can tell. You and me were meant to be in the great outdoors, forever free. You and me meant to be in the great outdoors.
So looking at the edges, they aren't perfect, but they'll be right. Maybe I should have run the 2 flute back over it just to give it a clean up, or maybe use a different tool from Cutwell's range. Might send them a little message and ask them for a bit of advice. They've been friendly when I'm speaking to them before. But yeah, there's a few burrs at the bottom, but that's fine. It didn't completely break through, but I set it like that. I need to clean up the holes, clean up the edges, go on the linisher, and just clean everything up, get on the Scotch Brite wheel, make it look pucker, and it'll be ace.
So you can see it's all together. I've put the cylinder on top, it's all placed on. I'm still waiting for the parts from Hawkins Engineering. That the connecting rod will go onto the end of this, it will screw in place, and it will connect to my lever arm, which will push down on my drawbar with the springs. I need to make the drawbar, but that's this piece that I was making before. I popped the bolt in for now. It's got some cool little shapes on it. Just kind of over designed the pieces that actually hold the arm that pushes everything down. But you can see it should be pretty tough. So pretty happy with that. Just need to finish it off, put some bearings into the bottom of these holes. And then we'll go on this piece. This other way. So this is the bit I've just made, as you can see. That'll bolt there. I've got 2 more spaces to go underneath here. To turn these little spaces up on the lathe. But yeah, I'll have some posts coming off these 4 holes, and then the bearings and that unit will be able to slide up and down. There'll be some springs on the inside to be able to push it up. Well, to the right position anyway. But just unscrew these. I'll show you my little spaces. They're just a cylinder, but when you make things yourself, it's always nice. So made these on a Myford Super 7. Kind of came out nicely. You just need to make 2 more. The 25mm long, just made out of aluminium. I get these anodized as well, and I have 1 there. There'll be 1 here, 1 here, 1 here, just to hold it. I think they're oversized for the job, but it'd be absolutely fine. Obviously you can see the belt drive, and you have a good idea of what's going to happen when it's being used. But obviously that's my tensioner, as I showed you before. So it's getting closer. I've got to make the front plate. I'll bring it down here, that will go on here. It's going to hold my my misting system, well, not misting system, but
the minimum quantity lubricant, or minimal quantity lubricant. I'd have 2 of them mounted here, so then I can get 2 directions, so then I can clear, like when I was making this piece, I was getting the material kind of jamming up in the slot when you're doing slot cutting. I've cleaned it all up anyway. I went on the linisher and got that working nicely, and then got on the buffing wheel, and I'd say it came out pretty nice. Don't know what you think, but I just thought I'd share with you guys, and each time I make a part for this I'll show you. And then once my automatic tool changer is done, well, it won't be automatic, this will be a semi-automatic because I'll be getting involved with it. But yeah, cool.